The idea that matter is made up of discrete units is a very old idea, appearing in many ancient cultures such as Greece and India. The word atom, meaning uncuttable, this word was first used by the ancient Greek philosophers Leucippus and his pupil Democritus, 5th century BC. An atom is the smallest constituent unit of ordinary matter that constitutes a chemical element. Every solid, liquid, gas, and plasma is composed of atoms. Atoms are extremely small. Atom is so small that we can't see it, we can only guess its structure. All valid assumptions about the structure of atom is called atomic model. Plum pudding model is one of the earliest model of atom proposed by Sir J. J. Thomson in 1904. According to this model, atom is a positively charged sphere on which negatively charged electrons are scattered around. For checking the validity of this model in 1909, Rutherford performed a scientific experiment. Plum pudding model can't explain that experimental result. Rutherford himself proposed an atomic model based on that experiment. Rutherford model, for the first time, gives us the correct picture of atom. According to Rutherford, every atom has positively charged center, called the nucleus, and around that nucleus negative electrons are orbiting. This model, in spite of giving the true picture of atom, has some limitations. Later in 1913, the physicist Niels Bohr proposed a model in which the electrons of an atom were assumed to orbit around the nucleus but could only do so in a finite set of orbits and could jump between these orbits only in discrete changes of energy corresponding to absorption or radiation of a photon. Niels Bohr used the basic idea of quantum physics. Till today, this atomic model is in use. So how does the atom actually looks? We are still using the concept of Niels Bohr, and according to this model, the inside of any atom looks like more or less like this. The atomic physics, or the science of atom, is mainly governed by quantum physics. That's why quantum physics is often called the physics of small things. The mass people showed interest in atomic science after Second World War. During Second World War, the United States detonated 2 atomic bombs over the Japanese cities of Hiroshima and Nagasaki on August 6 and 9, 1945, respectively. For the first time, world witnessed a massive atomic or nuclear power through this explosion. The nucleus inside the atom contains a huge amount of energy, and in an atomic bomb, that huge amount of energy is released in an uncontrolled way. That's why an atomic bomb is many times powerful than any other type of bomb. After Second World War, scientists had engaged themselves into the research of nuclear energy for peaceful use. Before knowing further about nuclear energy, we have to discuss what is nucleus. As we said earlier, that nucleus is the central part of an atom. It contains protons and neutrons. The number of protons inside a nucleus of a neutral atom is exactly equal to the number of electrons outside of the nucleus. Some heavy nucleus are so enriched with protons that those are not stable at all, they break down into stable lighter nucleus. This type of nuclear breakdown is assisted by the emission of huge nuclear energy and by the emission of nuclear particles. This event is called radioactivity. The element shows radioactivity is called radioactive element. Uranium, thorium, radium are some of them. Some elements are naturally radioactive, and some elements have unstable heavy nuclei but not radioactive, but can be converted into radioactive element by hitting them with energized small particles like high-speed neutron. For example, there are many different types of uranium available in nature, some of them naturally radioactive. Uranium-233 is one of them. And this naturally radioactive uranium atom spontaneously converts into lighter stable atom of some other elements. But there are also some other type of uranium atoms which are heavy and unstable but don't decay spontaneously. Uranium-238 is one of them. If a very high-speedy neutron hit this atom, then only it can break down into smaller, lighter, more stable atom of some other element. During this breakdown of unstable or heavy atoms nucleus, huge amount of nuclear energy are released. Nowadays, this release of nuclear energy can be controlled inside a nuclear reactor, and the nuclear energy is used to produce electric energy. You won't believe just 1 gram of radioactive element can produce so much electric energy. For producing same amount of electric energy from coal or from mineral oil, we need burn tons of those. If we consider the rate of energy production, then few grams of radioactive elements or nuclear fuel is equivalent to tons of other type of fuel. That's why atomic science or nuclear reactor engineering is continuously gaining popularity day by day. That's all for today, bye.